Hello, everyone. My name is Alexander Osorio, and here today with my team, we'll be presenting our communications management project. Here today with me, I have Francisco Solis, Juan Castro, Jesus Reyna, and Matthew Wilson. So, to begin with, we will first be talking about the abstract. And in the real world, nothing is perfect. BIM can help AEC grow and help us understand how to do better and more efficient construction projects. Also, BIM can help us understand how to communicate amongst each other in a more efficient way. Communication is a critical part of a project because it not only keeps everyone up to date, but it also helps with safety risks, errors, etc. The purpose of this study is to find solutions on how BIM can be implemented in communication management through the construction phases of a project. Also, how communication can help minimize safety risks by means of communicating through visualization and monitor information flow. Analysis of a variety of previous projects and learning what, where, when, and who on a specific project help us to understand how BIM can be used for projects. Our range of previous studies range from 2008 all the way to current date, which gave us a reliable and accurate information. The results are consistent and show how implementing BIM is a good choice for the chosen projects, and although BIM could not solve every problem at hand, BIM sure helped out in many ways, from leaving traditional ways of doing things to applying BIM as the alternative resource. Now, why BIM is important. BIM serves to help architects, engineers, and contractors plan, design, construct, and manage buildings more effectively and efficiently. In order to manage BIM, teams rely on BIM management software to track changes, collaborate, and communicate around the model. Recent studies have shown that all around the world, BIM is being implemented for all types of projects.
All right, so these are a few comments about BIM and communication management. So previously, when trying to portray an idea to an owner in a two-dimensional fashion, that becomes challenging because not everybody understands two dimensions. So whenever like regular people see a floor plan, a section, or an elevation even, they tend to have a hard time visualizing what their building is really going to look like at the end. So with BIM implementation and 3D modeling, it's much easier to and much quicker also to get an ideal model to put together, show the client, and let them know exactly what they're going to be receiving down the line. A BIM design usually begins with the architect. However, it should not remain alone. Uh, that pretty much means that everybody should collaborate together as much as possible. The building data model is therefore at the center of the design, and all project participants should have access to it, starting with the client, the architects, the engineers, authorities, et cetera, et cetera. Inherently, people know what they're going to produce at a job site, but they do not communicate that very efficiently with each other. And that's kind of one of the main issues that presents itself when you don't implement BIM. So how do you plan for communication management? This is pretty much the process of developing an appropriate approach and plan for project communications based on the stakeholders' information needs and requirements. The main purpose of this planned communications management process is providing a basis for which information will be delivered to who, when, and in what format. For example, should you send every detail about your project status to an executive manager or a vice president? Probably not. You should probably keep it brief, critical points, and just keep it short and sweet for the executives.
So some project inputs that BIM does stand for are to communicate and implement a better safety plan. Safety records show that safety is at all time low. To share information between supervisors and workers, to improve quality and scheduled by better communication, communicating with shareholders to keep them on track on the project and make it faster and easier, and faster and more accurate reports given. Some tools and techniques that BIM has also used before the system was well advanced was manual observations, gut feeling basically off their initial styles, experience of safety planner, 2D drawings, emails, and results error to do subject adjustment of the decision maker. And then after BIM, let's see, illustrates layouts, 3D remodeling, 4D simulations, visual training, geographic information systems, and results improved communications through the construction phases.
Output. Able partners to involve and communicate risk assessments and planning, identified issues and risk in timely, efficient manner, better narrated videos that you can actually implement in a meeting for supervisors and workers. BIM communicated a better way to plan in the phases of the project, communicate with site staff about risk and on the field. Overall, using BIM helped communicate the better safety plan, better ways to schedule the phases of the project. The way BIM helped the owner, partners, contractors, and workers is very different from traditional or standards ways of the BIM. Of that, BIM was able to help everyone see actual 3D and 4D animations that identify safety risk. The way BIM changed the language for everyone so they could understand was very significant. Because of means of visualization, everyone was able to understand what possible safety hazards and that can be avoided when on site. There is still a variety of changes that could be implemented in BIM software. Not every hazard can be avoided or communicated by BIM. Sometimes it does take experience or a gut feeling to avoid danger, but BIM is helping drastically.
So as
Honor to
far
communicate.
as so as far as the process of ensuring that the information needs of the project and the stakeholders are met, BIM has been very beneficial. So to start, BIM is able to create a 3D model, which is cheaper and less time consuming visual of the building. A 3D model makes it easier to show the proposed solutions and is able to create a simulation of the construction process, which helps to increase the knowledge of the way the building is going to be constructed, which helps to save time and resources. This also provides for better predictions since the deficiencies are more obvious. Also, all of this helps with quantity takeoff, and BIM also helps to keep a better control of quantities, which helps reduce the time spent on quantity takeoff. And the quantity takeoff can begin as soon as a 3D model, the renderings are done. And just to add to that, prefabrication of elements for the future facility can also begin as soon as the model is finished. More visible details are helpful, especially when communicating to the stockholders or the clients. This helps to show them or for them to better understand the final product. And all of this helps to provide better coordination between trades, which builds better relationships. So the previous slide basically talked about the benefits of communication with BIM, but just to add to that, instant updates on the project issues can be done. So with BIM, and a device, the workers can mark up an error on BIM and send it to the design team. And they can even take a picture of the main and attach it to the report so the design team can find the exact issue. And so they're also able to look up information faster. So let's say that an architect goes out to the field and they get asked for a measurement. They can, if they have a device on them, they can abstract that information and give it to the person a lot faster. This helps with the increase of collaboration between different trades. And just to highlight how this helps the stakeholders, so it is easier for them to understand a 3D model than a 2D plan, as one of my colleagues mentioned. And this helps with the communication of an expert versus a non-expert in the project. And it also provides them with a more accurate cost. And specific issues can be discussed. So let's say that this is a green building. They're able to create simulations and discuss them together, both the stockholder and the contractor.
All right, so in conclusion, based on the research that we gathered, it was really pretty easy to conclude that any organization that has the means and is available to implement BIM can reap many rewards from it. The main form of project delivery that we encountered in our research was that of design, bid, and build. This form of project delivery often tends to create an overall project structure that is fragmented in nature. So even though much of our research presented strong arguments as to why an organization should invest in BIM tools and capabilities, the flaws of its unperfected nature remained evident across a significant number of projects. This was mainly evident in how there was many cases in which collaboration wasn't very efficient. And that was mainly affected towards the MEP collaboration subcontractors. So the mechanical, electrical, and plumbers that were involved in the project, they often had a feeling of being left out and not being fully integrated into a project. And so that really just caused a lot of frustration and confusion amongst the field members that were in the ground actually building the project. And so for that reason, it leaves the door open to further research to investigate how you can improve that collaboration and pretty much give the MEP subcontractors more of a say in how they collaborate with the engineers and the architects and the contractors. So that basically wraps it up for us. And thank you for listening.